Hello people, welcome to the next video. So today we're going to talk about periodic table, which is the atom's house, and also the attractiveness of the atoms. So the learning objective of today is, firstly, you are going to be able to describe the arrangement of electrons in an atom using the following words: electron shell and valence electron. And also, you're able to draw atom's electron structure with the proton numbers from 1 to number 20. And also, you can answer the question, how does ionic bond form? How do atoms become ions? So firstly, let's pause the video for a second. Draw a neutral sodium atom, including a neutron, electron, and proton. Here's how the sodium atom looks like. So you can see that the proton and neutrons are clustered together in the center. That's our nucleus. And we have our electrons running around the outside. Your drawing might be different compared to this one. Take a look at this. You're going to have 3 different circles, and we call it shells. So 3 different shells. And the first one being the 2 electrons. The second one is there's 8. And the third one, there's only 1 on the third one. Okay, so firstly, I'm going to describe another way to say an atom. So here we have sulfur. The bigger number in here, 32.066, the number is the mass number, which means that the weight of a sulfur. Remember the mass number, which is a proton plus neutron, right? And the smaller number is our proton number. So if you subtract in between, you're going to get our neutron number. So 32 minus 16, you're going to have our neutron number. We're also using 1 or 2 letters to represent the element. We also call it the element symbol. And the first letter is always a capital. So here, sulfur only have 1 letter. It's a capital S. And you can see in the periodic table, we have lithium, which is a capital I, and small letter I. And the capital S, small letter I being another element. If we take a look at helium, the bigger number is our mass number, and the smaller number is our proton number. So if I wanted to know the neutron number of helium, I will simply use the bigger number to subtract the smaller number, giving me 2, which is the neutron number. The electrons being arranged in an atom. So the first shell can only hold 2 electrons, and we fill that shell first. And then we have 8 seeds on the second shell and 8 seeds on the third shell. So imagine the nucleus is like a football stadium. All the little cross meaning the seats available outside of the football stadium. So all the audience, when they come to see a football show, they want to come closer to the center as possible, right? You want to have a better view of it. So they will fill the first shell, the first circle of the seat first. 2 people comes in, filling the first seat. And then if we have any more electrons, they were going to go to the second shell, the second circle of our electrons and filling over there. If we have any more people, they're going to go to the third shell. So here's a rule to remember. The first shell only holds 2 electron maximum. Second one we hold 8 electrons maximum, and the third one is 8 as well. Electrons fit into shells around the nucleus, which is the center of the atom. And the outermost electrons, we call it valence electrons. So outermost electrons are valence electrons. So for example here, fluorine. You can see that fluorine has how many shells? It has 2 shells, right? And fluorine, the valence electrons of fluorine is 7. Okay, we have 7 electrons on the outermost shell. So take another look at calcium. And calcium, we have 1, 2, 3, 4. 4 shells in total. And the valence electrons is 1. So 1 single electrons on the outermost shell. If I react sodium with chlorine, this is what's gonna happen. So why do atoms react with each other? Why do innocent little sodium want to react with happily looking chlorine? Firstly, let's take a look at the atoms that do not react with the others. We call them noble gases, and they're on the right-hand side column of our periodic table. So if we take a closer look at their electron arrangement, you can see that the outermost electrons, being their valence electrons, is being filled up to the maximum. So the first circle, remember, you can only hold 2, so helium has the maximum number of electrons sitting there already. And same with the other 2 noble gases as well. So noble gases, they're chemically stable, which means that they don't react with the other very often. And they're looking like that. Oh, I'm so cool, I don't react. Because their outermost shell has been filled up. Remember, outermost shell electrons is our valence electrons. What about the other electrons? They want to react with the others or to form a stable arrangement to fill up their outermost shell into maximum numbers. Remember the first one being 2, and the second one being 8, and the third circle being 8 as well. So fluorine here, in this little fluorine, he wants to gain 1 electrons, right? Because he just missed only 1 electron to become super stable. Same thing with oxygen. Oxygen lady wants to fill up her valence electrons. She wants to gain 2 more electrons, right? So that she can have a very stable valence electron shell. You can see that sodium has only 1 electron left on the outermost shell. If the sodium atom simply just loses 1 electron, then it will become a sodium ion, and that will become stable. The world is going to be beautiful for sodium. Same thing happens with chlorine. Chlorine, on the other hand, just need just one more electron to be super stable. That becomes our chlorine ion. An atom becomes an ion when it loses or gains electrons. So it's a charged particle. It's charged because there's an unequal number of protons and electrons. For example, over here, sodium ion is Na+. Plus means it's positive. Why is it positive? In here, sodium atom, if it is stable, if it is neutral, then it will have the same number of protons with electrons, right? So in here, the electrons, when it's neutral, is 11. I'm going to write it over here. Is 11. That means that it will have the same number of protons. So my sodium wanted to lose 1 electrons, and in here the sodium has 10 electrons. So remember, proton is positive and electron is negative. So here, my sodium ion will have 1 more positive charge compared to the negative charge. So overall charges of the sodium ion is Na+. Same thing happened with chlorine. Chlorine, if you lose 1 electrons, in here, this is the proton number and also the electron number when it's neutral. If you gain 1 electron, the electron number will be 2 plus 8 plus 8. And the proton number doesn't change, right? It will be 2 plus 8 plus 7. So you have 1 more electron than the proton. Therefore, the chlorine will be a negative charge. So chlorine ion is a negative charge. The negative charge particles in the world will often attract with the positive ones, right? The same thing in human world. The opposite sex will attract with each other. Same thing with our little ions. The positive ions will be attracted to negative ion. And they here, our sodium and chlorine, that's why they react with each other, because they will form a positive charge and a negative charge, and they will attract to each other. And that is our table salt. Let's take a closer look. Sodium atom, you just need to lose 1 electron, right? Chlorine atom just need to gain 1 electron. So they kind of mingle up together, and sodium say, oh, I'm gonna give 1 to you, I don't need it anyways. And chlorine say, yes, yes, please give it to me. So both of them has 1 stable valence electron, and they become together. So atom will lose or gain electrons to form ions. And 2 ions of the opposite charge, they will attract with each other. The strong force in between each other is called ionic bond. So they attract each other, they have the strong force, and that forms ionic bond. Another example, magnesium atom. You can see that magnesium atom have two extra electrons to be super stable. An oxygen atom just need two more, so they kind of make an exchange. The magnesium atom gave those two to oxygen atom, and then magnesium atom becomes stable, and oxygen atom becomes stable as well. They're both happy. What happens if you have a magnesium atom and the chlorine? Well, you will need two chlorines to take away two of the extra electrons, right? Magnesium ion, you will form into 2+, and the chlorine ions will form into Cl-. You need two of them to take away the two extra electrons. That's it for today's video. Thank you very much. See you in class.